Hello everyone, this is Asim, and here we have a very simple example of magnetic circuits. In this example, as it says, we have three sides. We have three sides of this core are of uniform width, while the fourth side is somewhat thinner. The depth of the core is 10 centimeter, and the other dimensions are shown in the figure. Now, there is a 200 turn coil wrapped around the left. Here, this is a coil, and assuming relative permeability mu r of 2500, how much flux will be produced by 1 ampere input current? So we need to get R1 and R2. Now R1 here will be for the three sides that have the same width, and R2 is for the one side that have a different width from others. Now, why did we do that? Because whenever we have different widths, we have different areas, and then you definitely will have a different reluctance. And once this circuit is just one circuit, no current division and no flux division, so this means all the reluctances are connected in series. So this is like the circuit are shown here, just one flux going through all these resistors or reluctances, as we are dealing with a magnetic circuit. Now we should get R1 and R2. R1, as we said, R1 for the three sides, these three sides from here going through all this path to this point. So we have this convention. We will always move from the half of the length to the half of the length of the other side. In order to get R1, we have to get L1, and L1 for the three sides will be, here we have this 10 centimeters, so we have a 5 centimeter plus 30 plus 7.5, because 7.5 is the half of 15. Now here is also 7.5, and here's 30 plus 7.5 plus 7.5 plus 30 plus 5. Now as we do all the summation, we have a length of L1 equals 1.3 meter. Now E1 is the width of this sides, okay, because we are dealing as like two regions with same width, and the other region with which having R2 with different widths. And now we have to get E1 by the width of this region times the core depth as it's shown here. Okay, now E1 equals 15, because the width of this region is 15, times the core depth 10, we have 150 centimeters square, and E1 is this. Now R2 can be given from L2 divided by mu E2. So the same method we will do here. L2 is the length of this region. This is the region 2, because this one has different widths and this side has the same widths but are different from this one. Now L2 is 7.5 plus 30 plus 7.5, so this is L2, and E2 is the same method. The width of this region, which is 10 centimeter, and the core depth is 10 centimeter. Now this is E2. Now we have all the information needed to get all the reluctances. So here R1 and R2, we can get it from L2 and E2. And here, why did we do that? Because we are given only mu r, and mu r equals mu divided by mu 0, and mu equals mu r times mu 0. So mu r equals, it's given here, 2500 times 4 pi times 10 raised to power minus 7, which is a constant, is the permeability of free space. By having all this information, we can get the reluctances. Now, as we know, this magnetic circuit is just one circuit, so the flux will not be divided, so just one flux throughout the circuit. So this series reluctances will be connected in series. So to get the total flux, we have to get the total reluctances. As we get the R1 and R2, now we can get R equivalent by just summing them. Now here we have the R equivalent, this value, and now we can get phi. Phi if F equals phi times R. Okay, so now phi equals Ni divided by R. And here we can get phi if we have 1 ampere input current. And this is what we have here in the example. Okay guys, that's all. If you have any questions, please give me in the comments. Thank you, goodbye.